Welcome to your first training mission on the AH-64 Apache attack helicopter. I am Master Warrant Officer McNabbit, your instructor pilot for this training course. As a rookie aviator, we will first familiarize you with the cockpit, basic flight controls and systems. Then you will attempt to take off and practice the flight controls. As pilot of the Apache, you sit in the back seat of the aircraft. The front seat is occupied by your co-pilot stroke gunner, or CPG. Today, I shall be sitting in the front seat. I have disabled your controls and will hand over control to you when we come to practice the takeoff. You may look around the cockpit by pressing the arrow keys between the main and side keypads. If your joystick has a coolie hat switch, you may use that instead. To center the view, press the 0 key on the side keypad. Now take a moment to look around. Press the space bar when you've finished. Good. Now we'll quickly review the cockpit instruments. I shall point these out to you, and you will be able to learn more about them by reading the flight manual. The artificial horizon shows your attitude in relation to the ground. The airspeed indicator shows your current speed in nautical miles per hour, or knots. The vertical speed indicator shows your rate of climb and descent. The radar altimeter shows your altitude above the ground. The barometric altimeter shows your altitude above sea level. The compass shows the direction you are currently facing. The line on the compass is the direction to your next aircraft control point. The clock shows the current time of day. The radar warning receiver shows the location of enemy radar-guided SAM and AAA units. The center video display shows the infrared view from the Pilot Night Vision Sensor, or PNVS. There are 2 panels of warning lights in the cockpit. The caution stroke warning panel is down and to the right. There are 13 warning lights on this panel. Your flight manual describes what they mean. The master caution warning panel is above the PNVS display. These warning lights light up only in a serious emergency. Important though these instruments are, most of your flight and combat information will be available through your IHADSS display. IHADSS stands for Integrated Helmet and Display Sight System. It is a helmet-mounted sight that displays symbol and imagery onto a lens in front of your right eye. Briefly, I'll just point out to you the important elements of the IHADSS display. At the top of the IHADSS is the heading scale. The lubber line in the center of the scale indicates the helicopter's current magnetic heading. The arrow below the heading scale shows the direction to the next aircraft control point, or ACP. We will look at ACPs in more detail in the 3rd training mission. The solid arrow on the heading scale shows the bearing your co-pilot stroke gunner is looking along. At the bottom of the IHADSS is the TADS field of regard. It shows the direction the TADS, or Target Acquisition and Designation System, is looking in. Up and to the left we have the engine torque indicator. This gives engine torque as a percentage number. If you over-torque the engine, a box will appear around this number. Below this we have the airspeed indicator, which gives the speed in nautical miles per hour, or knots. To the right we have the altimeter. The digital readout gives the radar altitude in feet. Next to this is an analog altitude and vertical speed display. The arrow shows the rate at which the helicopter is changing altitude. If centered, as it is at the moment, the aircraft is not changing altitude. If this arrow moves upward, it means the aircraft is climbing. If it moves downward, the helicopter is losing altitude. The distance from the center line indicates how fast the aircraft is climbing or diving. The vertical scale shows the helicopter's altitude within 200 feet of the ground. This scale becomes solid as you climb until you reach 200 feet. Above 200 feet, the scale goes blank, and only becomes solid again when you dip below this altitude. In the center of the IHADSS is the line of sight reticle. This is the center point you're looking at. Also in the center, though you can't see it at the moment, is the velocity vector, a line which indicates your direction of travel over the ground. Near the velocity vector is a circle. This is the acceleration cue. I'll explain both of these symbols once we're in flight. Finally, to the right and left of the field of regard are the high-action displays. These indicate distance, range, and weapon data, and will be explained in future training missions. Now we have looked at the cockpit and displays, I will take you through the flight controls. These are the collective, the cyclic, and the tail rotor controls. The collective supplies lift by controlling the engine power and rotor pitch. Put simply, the more collective, the greater the lift. The amount of collective is indicated by the engine torque indicator to the top and left. This indicator is a guide to the amount of lift your rotors are generating and is measured on a percentage scale. You can increase collective by using the plus key and decrease it by using the minus key. Alternatively, you can use the throttle on your joystick if there is such a control. Increasing collective will cause you to climb. Decreasing it will make you sink towards the ground. Fine-tuning the collective in flight will allow you to balance lift and gravity. When you achieve this, you will hover. You can over-torque your engines, taking them over 100%. This increases wear on the engines, but allows emergency lift. When the engines are over-torque, a box will appear around the torque indicator. Aside from the collective, the other important control is the cyclic. Most of you will be using a joystick to control the cyclic, but you can also use the direction keys on the side pad of the keyboard as well. The cyclic controls the pitch and bank of the helicopter's rotor disc. Moving the cyclic tilts the rotors, causing the aircraft to fly in the direction of the tilt. If you push the stick forward, you'll fly forward. If you push it to the right, you'll fly sideways to the right. If you pull it back, you'll fly backward, and so on. A simpler way to describe this is if you imagine the main rotors as creating a column of lift, or thrust, downward, with the helicopter balancing on the top of the column. If you tilt the column forward, the thrust tilts backward, pushing the helicopter forward. If you tilt it to the right, the thrust is directed to the left and the helicopter flies right. The more you tilt the rotors using the cyclic, the more thrust is being used to fly forward or sideways or whatever. Of course, because less thrust is being directed downward, the helicopter will lose some of the lift that is keeping it aloft. Therefore, when you fly in any direction, you will usually have to increase the collective to compensate for the reduced lift. The final control is the tail rotor control. The tail rotors stop the helicopter from spinning due to the engine torque, and if they fail, the aircraft will go into an uncontrollable spin. They can also be used to yaw or point the helicopter in different directions. On the keyboard, you use the period key to yaw right and the comma key to yaw left. If you have a rudder control on your joystick, you can control the tail rotors by twisting the joystick clockwise or counterclockwise. Note that the tail rotors work best at low speeds or in the hover. At high speeds, they become less effective. Now that we've been through the instruments and controls, we will try some basic flight. I will now teach you to turn on the engines, climb to a hover using the collective alone, and then fly using the cyclic. Now, start the engines by pressing the E key. When the rotors are up to speed, increase the collective to around 90% and we will take off. Without touching the cyclic, I want you to use the collective to climb to 200 feet. When we approach this height, I want you to ease off slightly on the collective until our rate of climb slows and we go into a hover at around 200 feet. I would like you to try and maintain us at that height for a count of 5. You're too low. Increase the collective to climb to 200 feet. 2, 3, 4, 5. I have control. Good. You have managed to climb into the hover. We will now try to use the tail rotor controls. Carefully use the controls to face the helicopter due west. You have control. Come on, I haven't got all day. Face us due west. It's the big W on the heading scale. I have control. Good. You faced us west. Now try again and face us due east. You have control. I have control. Good. You faced us east. You now have the hang of the tail rotor controls. We will finish the lesson by getting you to use the cyclic. I will release the controls to you shortly. I want you to gently use the cyclic to make the helicopter fly forward. Remember to increase the collective when you tilt the rotor disc so as to prevent losing altitude. Once you have tried flying with the cyclic and collective, you can fly about wherever you wish. Try not to crash if you can. We can afford to lose you, but this is an expensive machine. You have control. Now you're flying at speed. Look at the velocity vector and the acceleration cue in the center of the IHADSS. The line is a representation of the helicopter's longitudinal and lateral ground velocities. In short, it shows you your speed and direction, as if you were looking down on the helicopter from above. The circular acceleration cue shows your acceleration in the same fashion. You have now mastered the cyclic control. You can now practice flying around using all the flight controls. Press escape when you wish to exit this training mission.